Welcome to The Explainer. Today, we're unpacking the fierce global race to diversify critical mineral supply chains and basically break free from a massive single point of failure. We're really looking at a fundamental shift in how nations power their futures and, honestly, protect their borders. Let's get right into it. So, what do modern fighter jets, massive offshore wind turbines, and the EVs sitting in our driveways all have in common? I mean, on the surface, they seem like completely different industries, right? The answer is rare earth permanent magnets. These things are the absolute linchpins of both the green energy transition and modern national security. Elements like neodymium give them incredible magnetic strength, while dysprosium keeps them stable at totally extreme temperatures. Whether it's an F-35 fighter jet or the motor spinning your EV's wheels, these specific materials are what literally make the modern world function. Here's our roadmap for today's explainer. We'll be covering the rare earth choke point, magnets, motors, and security, the midstream processing gap, Australia and global alliances, financial and technical hurdles, and finally, building long-term resilience. Starting off with Section 1, the rare earth choke point, and the vulnerability in the global supply chain. We often picture mining as this colossal, earth-moving endeavor, and well, it absolutely is. Just look at the sheer massive scale of raw extraction. But as we're going to see, the real geopolitical weapon isn't actually pulling the dirt from the ground. Simply having resources within your borders just doesn't equal supply chain security anymore. Moving right along to Section 2, magnets, motors, and security, and why governments are racing to secure supply. There's a pretty stark reality facing the U.S. defense industrial base right now. It relies heavily on foreign supply chains to manufacture essential systems. We're talking about radar chips, advanced penetrators, guided weapons. Actually, get this, a single guided weapon system alone uses 18 different critical minerals. When supply disruptions hit or export controls are slapped on, military vulnerabilities grow incredibly acute. You can't just pause national defense because you're waiting on a shipment of neodymium. This brings us to Section 3, the midstream processing gap, where we identify the true bottleneck. Okay, so here's where the actual leverage lies in the supply chain divide. While mining is spread out all over the map, Australia, for instance, produces about 47% of the world's lithium and has massive rare earth reserves. The critical value-adding step of refining is heavily concentrated. Refining is complex, and it's highly environmentally sensitive. It involves separating mixed concentrates into individual pure oxides. Basically, whoever controls this midstream step controls the entire market. To really anchor that reality, consider this staggering figure. China controls approximately 90% of all global refined rare earths. 90%. They've built this industry up over decades using state support and, frankly, an incredibly high tolerance for the toxic chemical waste streams that get generated by solvent extraction processing. And when I project out to 2030, we see a really severe imbalance. Notice how the mining sector is successfully diversifying across multiple countries like Australia and the US. But then look at the refining and magnet manufacturing capacity. Even factoring in planned projects, capacity outside of China remains a massive vulnerability. We're essentially mining the ore, but still having to send it away to be turned into the materials we actually need. Now for Section 4, Australia and global alliances, exploring the global counteroffensive. Right now, we're seeing two major but complementary approaches to tackle this. First, Australia's aggressive domestic push. Tired of just being a dig and ship commodity exporter, their government is using a massive $4 billion financing facility and a 10% production tax incentive to onshore refineries, like Iluka's Inaba facility. On the flip side, the U.S. is employing a global cooperative framework. Realizing they literally can't do it alone, they're aggregating allied purchasing power and creating unified trade zones through initiatives like Forge. A really fascinating strategy here is the push to establish plurilateral common price floors. This marks a massive shift from just transactional projects to a real systemic solution. See, in the past, whenever someone tried to build a refinery outside of China, the dominant suppliers could just temporarily flood the market, crash the price, and bankrupt the new competitor. A plurilateral price floor protects these vulnerable strategic investments from those predatory market fluctuations. It's a game changer. On to Section 5, Financial and Technical Hurdles, which is our reality check on diversification. Because, let's be honest, this transition is not going to be cheap. JP Morgan estimates it can cost up to 70% more to produce rare earth oxides in the US compared to China. Higher labor costs, stricter environmental and regulatory standards, and just a basic lack of existing infrastructure all contribute to this massive premium. And compounding that financial risk is a totally grueling timeline. It can take up to 17 years, yes, 17 years, to take a hard rock mine from initial discovery to commercial production. Developers have to navigate incredibly complex environmental reviews, secure permits, and raise billions in financing, all while the market price for these minerals is swinging wildly. This timeline severely impacts project viability and, understandably, makes private investors very nervous. Which brings us to our final section, Section 6, Building Long-Term Resilience and How We Escape the Requirement of Perfect Self-Sufficiency. So if 100% independence is completely unrealistic, what's the actual goal? Well, experts suggest that achieving just 30% partial diversification in supply is often enough to effectively break geopolitical leverage. You don't need total self-sufficiency. You just need enough alternative capacity to blunt the impact of an export control or a sudden supply shock. That gives you the flexibility to adapt without the whole system crashing down. One incredibly smart way we can hit that 30% mark is through a circular economy. Instead of always digging new holes, we can recover rare earths from end-of-life wind turbines, EVs, and consumer electronics using advanced extraction techniques like flash joule heating. Even more practically, we can implement co-product recovery. This means extracting rare earths from the existing waste tailings of other mining operations. It's really about working smarter, not just harder. Beyond recycling, we're also seeing incredible innovations that sidestep the problem altogether. The development of rare earth-free permanent magnets is fascinating, like the iron nitride magnets being pioneered right now by Niron Magnetics. They use globally abundant iron and atmospheric nitrogen instead of heavily concentrated rare earths. If we can swap these into EV motors and other specific applications, it completely bypasses that entire midstream refining choke point we talked about earlier. I'll leave you with this final provocative thought to ponder. We have the capital, we have the strategic alliances forming, and we're rapidly developing the technology to secure these critical supply chains. But do we have the sustained geopolitical will to actually see it through when the market fluctuates and the timeline inevitably drags on? That is the real test of our future resilience. Thanks so much for joining me for this explainer, and I'll catch you next time.